Hi, Narcademy here. So this time we're gonna learn about the different ways of expressing concentrations of our solutions. Now in the previous video, we saw that solutions contain two basic components, our solute and our solvent. And of course, our solutions, our solutes and our solvents have different quantities, and that will also affect the properties of our solutions because these quantities will now be used in different processes. Like for example, when your solution, different solution mixtures will undergo chemical change later on, their concentrations will affect how they will react with other substances. So in this video, we're going to learn about the general ways of expressing concentration of solutions, and then please bear in mind that whatever way or whatever I will be discussing, please put them in your notes so you will remember, because this is formula based. That means you need to put them down on your notes so you will remember. Okay, let's start. The first one is the basic percentage. When we talk about percentage, we talk about a certain amount of a component divided by the total amount of that particular system. In this case, if we talk about a solution contains solute and solvent. It may not be just one solute and one solvent. There are cases that you have more than one of each. So in this case, let's just make it general. If you're looking for mass percentage, mass, so that means the amount is in terms of mass. So if you want to get a certain component, say for example, just A, component A of your solution. So the mass percentage of A is always equal to the mass of that component in the solution divided by the total mass of the solution. So whatever you're getting, the amount of that will be put in the denominator, and always the numerator, sorry. The amount of that should always be in the numerator, while the denominator will always be the total amount, which is the same quantity, mass. Take note that mass in this case, because it's mass over mass, you need to be able to cancel out the units. So the units have to be the same. If one is in gram and then the other one is in kilogram, you need to convert either the gram to kilogram or the kilogram to gram so that the units will be the same. But the moment you divide, take note that you will get an answer that's always less than 1. Because this is percentage, you need to remember that right after dividing, you need to multiply it by 100. And because this is mass percentage and you're dividing mass and mass, you don't have any unit except in the final value, you just put the percent symbol and then you put the component you're looking for. Similarly, if you want to get another component, say for example B, mass of B will be on top, and then the total mass of the solution will always be in the denominator, then always times 100. Now, remember that your total percentages have to be equal to 100%. So if you want to get the percentage of all the components to check whether you're correct, is you need to add them, and it should equate to 100%. Is it possible to have volume percentage? Yes, it's possible. So if you have volume percentage, that means the one you place here are volume amounts, not anymore mass, taking into consideration that the volume units have to be the same. So more or less, they're just having the same pattern. If you have, this is the second one, if you have very small amounts, you will not use percentage anymore, but you're going to use what we call the parts per million ppm and the parts per billion ppb for very small amounts. So if you look at that, their basic equation is just the same, but the multiplier is not anymore 100 because we're not talking about percentage. Because it's parts per million, that means the multiplier is already 1 million. So after dividing, this is going to be, um, after dividing the masses, you just have to multiply it by 1 million. So you get a certain value from there. And then the final unit, you just put ppm of whatever you're getting. Similarly, for parts per billion, you multiply the quotient from here by 1 billion, then the final unit will just be ppb of whatever component you're looking for. So that's for ppm and ppb. Next is we have mole fraction. Mole fraction is symbolized by big letter X. So mole fraction is the fraction of the mole. Now take note, moles are units of is a unit in chemistry in which you express the amount of substances. You can get this from the molar mass of your substances. So moles for mole fraction is that in order for you to get a fraction, that means you have numerator and denominator. This is similar to the percentage basic formula, but this the units have to be in moles. So moles of substance A, if you're looking for mole fraction of A. So whatever you're looking for, that's what you put in the numerator. And of course, the denominator will always be the total, but the total value has to be in mole unit. So moles of A over total moles of the solution, that becomes your mole fraction. No multiplier, it's just like a ratio. And the moment you get this, the mole on top and the mole below units are cancelled out. That means you don't have a unit for mole fraction. Sometimes you are asked for the mole fraction of the solute, and sometimes you need to get the mole fraction of the solvent. In this case, if you have a mole fraction of solvent or another component, that's the same thing. Moles of that component on top over the total moles of the solution. Again, how do you get total moles of the solution? Just add all the moles of the components of your solution. Then that's your total moles. And always remember, mole fraction is always unitless, and the total mole fraction of all the components of a solution must always be equal to 1 because this is a fraction. So the whole is always equal to 1. So if you have two mole fractions, solute and solvent, when you add the two mole fractions, it should be equal to 1. That's how you check. Okay, that's it for mole fraction. Next is molarity. The basic formula for molarity is mole of solute divided by the liters of solution. Take note, liters of solution. So this is the total volume of the solution in liter unit, while the one in the numerator is the amount of solute in mole unit. So if you're getting for molarity, big M is the symbol for that. The unit becomes mole per liter, or also called big M, which is read as molar. So big M for the formula and also big M for the final unit. And take note, because volume is temperature dependent, molarity can change with temperature. Take note, that's a basic factor you need to consider. So this is for molarity. Take note, this is a very common unit you use for calculations, especially in the lab. So please remember about molarity. So mole solute over the volume of the solution in liter unit, not in milliliter but liter unit. So do your conversions properly before you proceed with your calculations. And lastly, we have molality, which is small letter M. Molality is mole of solute, so they have the same numerator with molarity, but the denominator is now the amount of solvent, but in mass kilogram unit. So kilogram of solvent. That makes the unit of molality mole per kilogram, or simply just small letter M again, and it's called molal. And because both moles and mass do not change with temperature, molality is never temperature dependent. So these are all the different basic ways of expressing our concentration of the solutions. Take note, you need to be able to memorize all of them to move further in your calculations related to solutions. So watch out for the next video about all these calculations in solutions. This has been Madam Narca saying don't stop learning, relearning, and unlearning. Till next time, bye.